Hi everybody, today I want to continue with the chemistry lecture for medical students with the periodic table. As you remember, in the last lecture I spoke about four quantum numbers, and which is the principal quantum numbers is describe about the shell, and the angular quantum number about subshell, and the magnetic quantum number we can know how many electrons can be in the maximum in the one orbital, and this spin quantum number, in every orbital we have a two spin with the same but different direction, positive half and the negative half. In the periodic table we have a main group from from 1A till 8A. These groups, okay, from 1A and 2A, they are s orbital filling. The first one is the alkali, and the second one alkali earth. Okay? Then I can say the first group is the alkali. Okay? Metals which start from the lithium. But the first element in this exception is the hydrogen. Okay? Hydrogen in the top of the group 1. Okay? Plus hydrogen. Then we can say lithium, sodium, potassium, rhodium, cesium, and francium. Okay? All of these elements has an ns1. Okay? As you see here, in the orbital of S, they have just one electron. Okay? Mainly, they like to lose this electron and they become more stable. Okay? And mainly, with loss of this electron, okay, minus one electron, become cation. For example, become the cation. Okay? And the second group, it is the alkali earth. Okay? And the alkali earth elements start from the beryllium, magnesium, calcium, strontium, barium, and rhodium. All of these groups has a ns2. Okay, compared to the alkali, they are more stable. Compared to the alkali, they are more stable. As you remember, they are more stable because they have a full s orbital. Okay, and the number of the electrons is the maximum 2, and it will be 2. Okay? After second, but then I can draw here a small periodic table. Okay? This is the hydrogen. And this is the second group. This is the ns1 alkali, ns2 alkali earth. After that, okay, as you see here, then start the transition metal, okay, which is not belong to the main group, okay, and then it is a 10th group D, we will study later, and after that we will have a group 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, okay. The third group is the boron family. Okay, this is the boron family with the formula of ns2 and p1. Okay, and the element of this group is important because start with the boron, is very important, B, and the second one is very famous metal is the aluminum. It's very important. Okay? And the boron is the metalloid, and after that we go the other groups, as you see here. Boron is the non-metal, and aluminum is the metal. Okay? It is important for this section. And we have a germanium and other element we will study later. But for the medical student, this two is the first two element is very important. The other group is the carbon group. It's very important for example, for the organic chemistry, carbon group. With NS2, MP2. In the ground state, they have a 2 electron in the S and a 2 electron in the P. But it's unstable. 1 electron can jump here and become NS1 and NAP3. It can be hybridization, we will study later, and it's very important carbon group, okay? Carbon group is very important, we will study later, and in the carbon group, we have a carbon and the silicium and other element. Okay? Okay? This one is the S block and it is a P block. It's very important. This is the S block. This is the S block. S block. And it is a P block. And D here is the D block. We will study later. And after carbon, it is nitrogen group. Nitrogen group with the formula of NS2 MP3. It is more stable because it is a 2 electron here, and according to the Hund rule, it has a 3 electron in the p orbital. It is very important for the P group. And the nitrogen group is very important because in this group we can find also phosphor and other elements we will study later. And the next group is the oxygen group. Group 8 is the oxygen group. Oxygen sulfur. As you see here, oxygen group. It is the formula NS2 NP4. It has a 2 electron. It needs a 2 electron. Okay. In this situation, we can find the anion form because oxygen can accept electron easily from the metals also. Okay, it is very important, and we have to care about this. And the last group is the halogens: fluor, chlor, brom, iodine, bromine, iodine. And this group has the NS2 and MP5, which the fluorine has the highest electronegativity. NS2, MP5. They love electrons because if they accept 1 electron, become Nobel gas, then we can write this formula. They are halide form. Fluorine, chlorine, bromine, iodine. With accept electron can be stable. Okay. And the last group is the Nobel gas. We start with the helium. It's very easy. Helium, neon, argon. They are stable and they are uniatomic, and they are full shell electron, and S2 and P6. It is very important. We have to care about this. And as you see, and in the middle we have a D block or transition metals. Okay? Okay, we can say 1A, 2A, 3A, and this, or we can say 1, 2, and here is a 10, and we can go until 18. But we have two forms, but it's a D block, it is transition metal, and also we have F block from here. F block, it has a transition metal, it has a 10 groups, 10 rows, and F has a lanthanide actinide, that is a 14. Lanthanide and actinide. This both of them, lanthanide and actinide, are F blocks, and it has a 14 electron. Now I small explain about the quantum number also. As you see here, when we have a quantum number 1, n equal 1, l equal 0, and m, we have it just ml is just a 0, and we have 2 spin. In this situation, we have just two options. This one is for the n1. Okay? And this, if we have n equal 2, l is equal 1, ml between -1, 0, positive 1, 3 place, then we can have these 2s here and 6p here. And from the transition side, we will have a go to the n equals 3, and with the lanthanide and actinide part, we go to the n equal 4, l is equal c. The other things in the periodic table is very important, and I explain it. Very important. If you go to make a direction like this, as you see, okay, in this direction we can find mainly metals, and if we go this direction, we can find mainly metalloids, okay, non-metals. And between these, they are metalloids, okay. It is very easy. For example, from the group 4 is the boron is the metalloid, aluminum is metal, and from the carbon group is the silicium is metalloid. From the nitrogen group, also we have arsenic is the metalloid, and from the oxygen group we have a thallium, and with the halogen group we have a astatine is the metalloid, and other is the metal. Then non-metal here, then I can draw here, this is a metalloid, and like this, we have a one row here, they are metalloid, which is important, and we have to care about it because it is a semi-metal metalloid. Now we go to the property about the atomic radius. From the left to right, radius decreasing. Okay, then I can easily say, if we go from the left to right, radius decreasing. I can write very easy. How does it goes? From the radius, from this direction, radius decrease. From the up to down, radius increase. Then, okay, it's very easy. Left to right, radius decrease. Up to down, radius increase. Or we can say easily, from the down to up, radius decrease. From the left to right, also radius decrease. It's very important. We have to care. Also, there is other things very important, always in the periodic table. Element, okay, but metals like to lose of electron and become cation. Cations are less radius than the elements. For example, if I have a sodium and sodium plus, because with the loss of an electron, it goes back to the noble gas before it, and in this case, sodium radius is more bigger. Okay, and in the halogen, for example, if I have bromine and bromide, because accept the electron and the shell is complete, the radius is become bigger because it is very important, because the negative charge and the last shell will be complete, and the radius will be more. And then anion is more, it will be bigger than neutral element, and cation is always smaller than cation is smaller than cation is smaller than element. Okay. Now I go to the first ionization energy. Okay. In the periodic table, the first ionization energy is the energy need to remove the highest energy electron from the neutral atom. Okay. For example, if I want to take one electron out, okay, needed to remove, okay, then the element can be cation, okay. As you remember, it's very easy. For example, as you see here, okay, if we go from the periodic table from the right to left, okay, from the right to left, ionization energy decrease. Because, this, for example, alkali and alkali earths has the lowest ionization energy because they like the loss of electron, loss of electron. But the noble gas never likes the loss of the electron. It's very important. It's very important. Then the, as you see here, the noble gas has, okay, highest ionization energy. Okay. Also, according to Hund rules, when the subshell, for example, in the P3, when we have 3 electrons in the P orbital, when it is filled, also in this case, ionization energy is increasing. Okay. For example, nitrogen ionization energy, okay, is a little higher. Okay, because when we go to this direction, ionization energy must be decreased. But the ionization of nitrogen is more than oxygen. It's very important. Oxygen lower than nitrogen. In this case, we can say, according to Hund rule, and also the noble gas, which is the full orbit, full electron in the orbitals, they have a higher ionization energy, the highest for the noble gas. And if we go from the noble gas to the left, ionization energy decrease. But there is exception. Right? You see, decrease in the nitrogen, increase a little, again decrease, and also in the alkali earth increase a little, and again sodium, the alkali earth a little increase, again the alkali decrease. For example, I draw one example, and here, and you can understand what I say for the one group. For example, I go from the neon, okay, neon is the highest, okay. I go to the second one is fluorine, okay, oxygen. When I go to the nitrogen, it must go down but nitrogen, because Gundul is the half subshell is the 4, it's a little increase, it's the nitrogen. Again, decrease carbon, boron. Again, a little increase for the alkali earth, then again sodium. If you see here, the nitrogen is mainly important, is a little increasing, and the alkali earth, for example, magnesium or beryllium, has higher compared to the others. You see, decreasing, but in the sodium and the beryllium is a little higher compared to the neighbors. Okay, it is one of the important things we have to care about. Ionization energy, and the other things, the electron affinity, the energy change for the process when we adding electron to the neutral atoms. Okay, it's very important. Alkali earth, metal, and the noble gas is they are highest, because for this group we cannot add more electron. It's very important. In the electron affinity, alkali earth and noble gas is the highest, because we cannot add more electron. No place. It's very important for the electron affinity. Then I can explain very easily. Okay, as you see here, electron affinity. These two groups is the highest. Okay, then the other groups is less. Okay, and again from the right to left, again electron affinity decrease. Okay, because adding electron for the metals is very hard, and from the up to down also electron affinity decrease. It is very important, but just I have to mention about this. Electron affinity is very important, and metals don't like accept the electron. Okay, it's very important. Okay, electronegativity is very important. the ability of the atom to draw bonding electron, okay, to itself, okay. And as you see, the electronegativity of the fluorine is the highest. It's almost it's equal to 4. Okay, from the fluorine, because the noble gas hasn't any electronegativity, and from the fluorine gas, if we go down or to the left, the electron affinity decrease. It's very important, and we have to care about this. And thank you very much for this part. I finished the first lecture. I hope it will be good. We will see in the next lecture. Thank you very much, and have a good time.